Hello students, welcome back to my channel. In this video, I am going to discuss in detail about the multiple choice questions based upon the electrochemistry. Electrode at which electrons flow into the electrolyte is. In general, at the anode, electrons will be liberated, and at the cathode, electrons enters into the solution. So option B, cathode, is the right answer. Which of the following reaction occurs at anode during the electrolysis of copper sulfate solution using copper electrode? So whenever copper sulfate solution is electrolyzed by using copper electrode, that means the electrodes are active. So at the anode, copper electrode slowly dissolves. So option A, that is copper will dissolve, resulting in the formation of Cu plus 2 ions with the liberation of 2 electrons, is the right answer. During the electrolysis of the anions and cations of the electrolyte, what happens? So undoubtedly, during the electrolysis, both anions and cations will be discharged electrically. So in this case, option C, that is electrically discharged. So during electrolysis, both anions and the cations will be electrically discharged. In which of the following electrolysis electrodes act as active electrodes? So during the electrolysis of, when the electrodes will be active, active means if the electrode is made up of the same metal used for the preparation of electrolytic solution. So here graphite and platinum are inert electrodes. So the electrolysis of aqueous AgNO3 solution between Az electrodes will be active. So in this case, option C is the right answer. So coming to the fifth question, the electrolysis of which electrolyte gives the same products in the fused state as well as in aqueous solution state? Fused state means that is in the molten state. So only the electrolyte will be present. Aqueous solution means along with the electrolyte water will be present. So especially the noble metals. Noble metals means once you remember electrochemical series. So electrochemical series can be divided into two important regions. So the metals which are present above hydrogen are active, and the metals which are present below, they are called as noble metals, especially copper, silver, gold and platinum will be present. So in the case of noble metals, so when their molten solution as well as aqueous solution is electrolyzed, then they give same products. So here in the given options, option C, that is gold chloride, is the right answer. On the basis of the position in electrochemical series, the metal which displaces hydrogen from water and acids is, as I said earlier, so the metals which are present above hydrogen, that means they include lithium, sodium, potassium, magnesium, zinc, aluminium, iron, lead, etc. All these metals are active and they are capable of displacing hydrogen gas from acids and also from water. So in this case, here aluminium is the right option. The cathode of an electrolysis and a reducing agent are similar because both. So especially whenever if we consider the process of electrolysis. So whenever if we consider the process of electrolysis, always at anode oxidation takes place and at cathode reduction takes place. So what is meant by reduction? Gain of electrons. That means cathode is capable of supplying the electrons. So cathode will supply electrons. And coming to the reducing agent means itself undergoes oxidation. That means let us consider one simple example, that is zinc. So zinc undergoes oxidation and it liberates two electrons. So it undergoes oxidation means it can act as reducing agent. That means reducing agent is also capable of supplying electrons. So in the case of electrolysis, both cathode and reducing agents will have similar behavior and they always supply electrons. In an electrolytic cell, cathode acts as. So as I said earlier, here at the cathode what happens? Reduction takes place. That means cathode is capable of supplying electrons. Supplying electrons means it can able to reduce other elements. So it can act as reducing agent. So in an electrolytic cell, cathode acts as reducing agent. The amount of ion discharged during the electrolysis is directly proportional to. So especially it is directly proportional to the strength of the electrolytic solution. In the Daniell cell, which electrode acts as? Daniell cell means it is nothing but galvanic cell, and galvanic cell consists of zinc and copper electrodes, and zinc electrode will act as anode. So option C is the right answer. The molar conductance of HCl is more than that of NaCl. So definitely the molar conductance of HCl is greater than NaCl, since the mobility of H plus ions is more than that of Na plus ions. The units of electrochemical equivalent are. So according to Faraday's first law, W is equal to ECT. That implies E equal to W by CT. That means units are gram per coulomb. So option D is the right answer. During the electrolysis of brine, 710 grams of chlorine gas was liberated at the anode. The weight of NaOH formed. So here brine solution is used. That means NaCl dissociates into Na plus Cl minus. For the convenience, let us consider 2 moles of NaCl. Then it results in the formation of 2 Na plus 2 Cl minus. So at anode what happens? The anions will be discharged. So 2Cl gives rise to Cl2 gas with the liberation of 2 electrons. And at the cathode what happens? 2Na plus will gain 2 electrons and it results in the formation of 2Na. And here H2O is present with the result 2Na plus 2OH minus will gives rise to 2NaOH. So NaOH will be formed at the cathode. Here what is the weight of the chlorine? 710 grams of chlorine is formed. So what is the atomic weight of chlorine? 71. So 10 times chlorine gas is liberated. So applying the same principle, at the cathode what happens? 2 moles of NaOH is formed. At the anode only 1 mole of Cl2 gas is formed. So we have to multiply with 10, 20 moles. And what is the atomic weight of NaOH? 40. So finally it results in the formation of 800 grams of NaOH. So 800 grams of NaOH will be formed. the weight of copper deposited by passing 0.5 Faraday of current is. So generally whenever 1 Faraday of current is passed, then it deposits equivalent weight of the substance. So what is the atomic weight of the copper? 63.5, and its equivalent weight is, so Cu is present in the +2 state, so we have to divide with 2, and that is equal to 31.78. So here 0.5 Faraday of current is passed, that means divided by 2. So finally it results in the formation of 15.875 grams of copper. So option C is the right answer. Calculate the standard EMF of the cell, cadmium and copper. Here the electrode potential of cadmium is minus 0.44 volts and the electrode potential of copper is plus 0.34 volts. So always an electrode with higher potential will act as cathode and the other electrode will act as anode. And how to calculate EMF? So EMF of the cell is equal to E cathode minus E anode. That implies 0.34 minus of 0.44, and that is equal to 0.78 volts. So in this case option D is the right answer. On passing 3 amperes of current for 50 minutes, 1.8 gram of metal was deposited. The equivalent mass of the metal is, so it is Faraday's first law. So here we have to use the Faraday's first law, that is W equal to ECT. And we are supposed to calculate equivalent mass. Equivalent mass means we are supposed to calculate capital E. And always remember small e is equal to capital E by F. That implies Faraday's first law can be written as W equal to capital E CT by F. So that implies equivalent mass is equal to W into F by CT. So on substitution, that is 1.8 into 96,500 divided by 3 into, here the time is given in minutes and we have to convert it into seconds, and on calculating we will get 19.3. So option C, that is 19.3 is the right answer. The potential of two electrodes used in the cell are 0.35 volts and minus 0.85 volts. What is the EMF of the cell formed? So here one electrode is having the potential of 0.35 volts and the other electrode 0.85 volts. So always the electrode with higher potential will act as cathode and the other electrode will act as anode. So we know that EMF of the cell is equal to E cathode minus E anode. So on calculating you will get 1.2 volts. So option A is the right answer. The reaction half H2 plus AgCl gives rise to Hg plus Ag. This can be represented in the galvanic cell as. So in the galvanic cell always we have to represent anode half reaction followed by cathode half reaction. Here hydrogen will act as anode. So it undergoes oxidation. So hydrogen electrode is acting as anode and it is made up of platinum. So platinum H2 gas will be oxidized to HCl and here salt bridge will be present and Ag plus ions from this AgCl solution will be reduced to silver and hence it is the representation of galvanic cell. So here in this case, option D is the right answer. Which of the following energy changes occur in galvanic cell? So galvanic cell is known for the conversion of chemical energy into electrical energy. So option C, that is conversion of chemical energy into electrical energy, is the right answer. Which of the following will increase the voltage of the cell? Tin plus 2 Ag plus gives rise to 2 Ag plus tin ions. So in a cell, always the voltage can be increased either by increasing the concentration of Ag plus ions or by decreasing the concentration of Sn plus 2 ions. So here in this case, by increasing the concentration of Ag plus ions, the voltage of the cell can be increased. So option B is the right answer. The purpose of salt bridge in galvanic cell is to prevent. So here what is the purpose of galvanic cell? In the galvanic cell, it can prevent the accumulation of charges around the electrodes. The potential of a single electrode depends upon the nature of the electrode, temperature, and also electrolysis. So all the above is the right option. Find the strength of the current used if 1.3 grams of zinc is deposited from zinc sulfate solution when it is electrolyzed for 200 seconds. That means here we have to use again Faraday's first law. W is equal to ECT and W is also equal to capital ECT by F. That is equal to, here we are supposed to calculate the strength of the current. So C, that is equal to WF by ET. And hence that is equal to 1.3 into 96,500 divided by 32.65 into 200. So here the atomic weight of zinc is 65.3 and always zinc is available as Zn plus 2. So we have to divide by 2 and then we will get equivalent weight as 32.65. So on calculating you will get 19.22. So here in this case 19.3 amperes is the right answer. The standard EMF of Daniell cell is, here the Daniell cell means it is nothing but galvanic cell and it is made up of zinc and copper electrodes, and always the EMF of the galvanic cell, that is Daniell cell, is 1.1 volt. A solution of sodium sulfate in water is electrolyzed using inert electrodes. So in water means it is aqueous solution, and hence always at cathode hydrogen gas will be liberated and at anode oxygen gas will be liberated. So in this case option A, that is H2 gas and oxygen gases will be liberated at cathode and anode respectively. That is all about the multiple choice questions based upon the electrochemistry. If you like the video, don't forget to like, share and subscribe. Thanks for watching. Have a nice day.